Hi, Sam Roberts here from Roberts Geospatial. Today I want to show you how to get some GLO-30 DEM data into ProRaster Scientific. So GLO-30 is a global digital elevation model that's provided by the European Space Agency, get it from Copernicus, and it's derived from the world DEM data. So it's very high resolution. It's 1 arcsecond resolution, about 30 meters, and very high quality, and probably the best high resolution free global DEM dataset available in the world today. So I'll just bring up File Explorer. So when you download this stuff, today we're going to look at New Caledonia. I've downloaded, you can download it by region, so I've downloaded New Caledonia. You get a bunch of tar files, and when you unzip them, you get this directory or folder structure, quite verbose. So within these folders you have the DEM data, which is in a TIFF file, and we'll be looking at that. And the other thing that we're interested in is the WBM TIFF, which is the water mask, and we'll be using that to mask the the DEM data and take all the ocean out of the data set. So that's our data. I'm going to go in and I'm going to create a raster source for the DEM data. So just going to add a new raster source. I'm going to call it New Caledonia DEM. That's okay. I'm going to select all of those TIFF files. Where is it? There it is. So from this New Caledonia directory, and I only want the ones that are called dem.tiff, so I'll just select those ones in particular. So there they are. Some of them are mostly water. Hit OK, and it will render those immediately. Now it looks quite funny because each tile gets rendered individually, so the color stretch is individual for each tile, and also the intensity, the sun shading, and that can go pretty bad when you've got tiles that have got almost no data in them whatsoever. Anyway, we also want a raster source for the water mask. So let's add a new raster source, and I'll call it WBM for the water mask. Again, we want to select the TIFF files from that folder. This time I only want *WBM.tiff, and if we have a look at that, we've got all of our WBM files. And here's our water mask. Now this is one of these situations where the TIFF file gets loaded by the engine, and it thinks that it's imagery, but it's not imagery at all. And of course it looks funny. So if we add in a LUT layer and select that, you get something that looks a little bit less silly. Change the color transform to a manual transform. So these WBM files are actually classified rasters that are stored in TIFF files, and they need to be worked with separately, and that'll be subject of a future video. So now we're going to do some processing. I want to mask the DEM by the water to remove all of the ocean. I'm going to keep the rivers and the lakes, and I'm going to keep the land. So let's get rid of that algorithm again. I'm going to processing. So I'm going to create a raster mask from my WBM raster source. My output file name is going to be WBM mask. And I want to accept all data values except 1. So 1 represents ocean, whereas 0 and 2 and 3 are land, rivers and lakes. So let's go A00, which is the name of our variable up here. not equal to 1. So if it's not equal to 1, then we're going to keep the value. And if it is equal to 1, then we're going to return null. Hit OK. So there's our mask. Looks all right. Turn the intensity off. It's just showing us here's New Caledonia and the islands around it. Okay, so that's fine. Now I want to do a clip to raster operation. So I'm going to clip my DEM data to my mask. I'm going to output DEM masked. Hit OK. Okay, so now we've got something. We have a DEM data clipped to the ocean, clipped to the mask. All the ocean has been removed. Rivers and lakes are still in there. So that's what we want. Now let's export it out to an MRR file so that we've got something permanent and efficient. So I'll go export operation. We're going to want DEM masked as our import. Our output will be DEM masked export. We're going out to an MRR file. I want to get the maximum possible compression, so I'm going to go for quality compression. And in the advanced settings, I'm going to set a few things. So firstly, I've got some raster metadata, which is just a text file which contains some information about how the data was obtained, where it came from, what the licensing is, and so forth. So I'll just include that in the MRR file so that we can see it in future. I'm going to use predictive encoding using previous value linear. That's going to improve my compression. But predictive encoding works on integer data. You can use it for real data, but it's best for integer data. And in order to do that, I'm going to employ this data type and data transform operation. So my user-facing data type is floating point 32-bit real. But my storage data type is going to be an unsigned 16-bit integer. And then I'm going to scale and transform my real data into an integer data for storage. So what that will do is it will round off the elevation values to the nearest 20 centimeters. And for 30-meter resolution data, I think that's entirely appropriate. So I'm going to put in an offset and a scale, and you can check those things via these formulas to make sure that you're doing the right thing. And so what we're doing here is we're transforming our real data, which has sort of 5 decimal points of detail, which is ridiculous, down to integer data, which when scaled back is the equivalent of a 20 centimeter resolution in the vertical dimension. So let's hit OK. And we're all set up, hit go. So we're now outputting to an MRR file. So we're sucking in all of those TIFF files. We're doing all of the water masking, taking all the ocean out of it, and computing statistics. We're computing overviews and outputting it all to a single file. So let's go out to here. So here's our output file, demmasked.export. I'll drag that in. It's a new algorithm. So here's our MRR file displayed in ProRaster. Down here is, so this is the main island of New Caledonia. Down here is the port of Noumea. Perhaps if we just put some Google Maps on top, you can see that we're at Noumea, and you can even zoom in and find a boulangerie. In there, there's a few good places to go and eat. And just as a comparison, what we've achieved here. So New Caledonia, we got all this data. Let's have a look at the properties. So it was almost a 2.5 gigabyte download, and we've turned that into an MRR which is 26 megabytes. So in terms of efficiency, we've improved our efficiency by a factor of about 100 by turning that data into an MRR file. And there it is. So that's how to get GLO-30 global digital elevation model data into ProRaster Scientific. Thanks for watching.